Hi guys. Alright, FST, you guys are just starting chapter 8. So, if you look in your book, chapter 8 is on sequences, series, and combinations. So basically this chapter is kind of a big hodgepodge of a bunch of stuff that we haven't really elaborated on very much yet. We're going to talk about different sequences. We're going to talk about arithmetic sequences and geometric sequences, which we've already hit on a little bit. We're just going to kind of elaborate on them a little more. And then we're going to get into series. Basically a series is just like a sequence, except that you're actually adding all of the successive terms. And then we're going to talk about limits. This is a pre-calculus concept. It gets really heavy in calculus. Limits are basically just if you were to continue some sort of sequence forever and ever and ever, what would it look like towards the end of that sequence? So we'll talk about limits for a series. Then we'll get into combinations, which are based on probability, so they're a lot like permutations, which we looked at in chapter 7. We will connect that with Pascal's triangle and the binomial theorem, which will help us out for chapter 9, where we're going to get into some more statistics. Okay, so section 1 is called formulas for sequences. So a sequence is a function whose domain is a set of consecutive integers greater than or equal to k. So essentially, when we have a sequence, all of our domain values are 1, 2, 3, 4, 5, 6, etc., etc., and your range is the actual values of those terms. So your terms are just your first term, your second term, your third term, and those are your domain values. And your range values are the actual values of each of those terms. So each element in the range of a sequence is called a term of the sequence. The corresponding positive integer in the domain is its position in the sequence. So in the sequence of square numbers, our domain consists of the positive integers and the range consists of the squares of those numbers. So this would be an example of a sequence where my domain is 1, 2, 3, 4, 5 all the way up to n, and my tiles are 1, 4, 9, 16, 25. So I'm using the squares of those numbers. For the square numbers, the formula a sub n equals n squared is called an explicit formula for the sequence. An explicit formula is a formula where you can just plug in the term that you want. So if I want the 10th term, I would plug in a 10. And I just plug in that term and it automatically gives me the actual value of that term. Okay, in contrast, a recursive formula is one where the first few terms are given and then the nth term is expressed using the preceding terms. So for the square numbers, our recursive formula would be a sub 1 equals 1, because that's my first term. A sub n equals a sub n minus 1 plus 2n minus 1. So essentially this is my new term, this is my previous term, and I'm adding 2 times n minus 1 onto my previous term to get to my next term. An arithmetic sequence is one in which the difference between consecutive terms is constant. In other words, you're adding or subtracting every time in order to get to your next term. For example, if you have 1, 3, 5, 7, 9, that would be an arithmetic sequence because I'm adding 2 every time to get to my next term. So my constant difference would be 2. If we know the first term and the constant difference of an arithmetic sequence, we can write an explicit or recursive formula for the sequence using these formulas here. So for explicit, we just say a sub n equals a sub 1, that's my first term, plus d, which is my constant difference, times n minus 1. For my recursive formula, I just start by saying a sub 1 equals whatever my first term was, a sub n equals a sub n minus 1, my previous term, plus d for all n greater than 1. So remember that d is your constant difference in that case. So let's do problem number 1. I want to find the explicit and recursive formulas for this sequence here, 1, 3, 5, 7, 9. First thing I'm going to notice is that my first term is 1, and my constant difference in this case is 2, because I'm adding 2 every time. So for my explicit formula, I'm going to follow this format here. I have a sub n equals my first term plus my constant difference times n minus 1. That's my explicit formula. For my recursive formula, I'm going to start with a sub 1 equals 1. Then I'm going to have a sub n equals a sub n minus 1 plus 2 for all n greater than or equal to, should be 2. Okay, next up we need to talk about geometric sequences. So a geometric sequence is one in which the ratio of consecutive terms is constant. In other words, I'm multiplying by a number sometime. So every time I multiply or divide by some number to get to my next term. So for example, 1, 2, 4, 8, 16 would be a geometric sequence because I'm multiplying by 2 every time to get to my next term. So in this case, the constant ratio is 2. If we know the first term in the constant ratio, we can again write an explicit and a recursive formula for this sequence. So here are generalized formulas here. So if I want to find the explicit and recursive formulas for the sequence 1, 2, 4, 8, 16, the first thing I'm going to say is that my first term is 1, and my constant ratio is 2. So if I plug that into this explicit formula, I have g sub n equals 1 times 2 to the n minus 1. Then, to get my recursive formula, I can say g sub 1 equals 1, g sub n equals 2 times g sub n minus 1. Okay, so there's my explicit and recursive formulas for those that geometric sequence. And that is everything for section 1.